apologize for the shaky camera. I have it sitting on a book right now, which probably isn't the best way to shoot this thing. A tripod might be a little better, but we're gonna have to deal with this for today. So, jumping into problem number 19 on page 401. All right, so let's go ahead and read it. It says the pyramid. I don't know why I wanted to say pyramid. I don't believe that's a word. But look it up, and if it is a word, shoot me an email and say, hey, you're so cool, you just said a word that I've never heard of. Okay, the pyramid shown below has altitude h and a square base of side m. The four edges meet at V, the vertex of the pyramid, and each have length e. If e equals m, what is the value of h in terms of m? All right, so lots of unknowns going on here, e, h, m. Let's ask our 5 questions. Who, what, when, where, and how. First and foremost, the what question. What kind of problem is this? This definitely looks like a geometry problem because I see a figure and they're talking about pyramids and square bases, and so this is a geometry problem, although it's a little bit an algebra problem in disguise too, since we have all these unknowns. Jumping to the when question, how much time do you have in this section? This is 19 of 20 in this particular section, so you probably aren't going to have a whole lot of time to complete this problem. So if this looks like something that might be tough for you, you might want to jump to number 20, take a look at that, and see if it might be easier if you're running out of time. Next, the where question. Yeah, we just answered that. This is number 19 of 20. So it's going to be a hard problem, and in fact the College Board ranks it 5 out of 5 on the difficulty scale, 5 being the most difficult. So you're not going to know that, but you are going to know based on the fact that it's towards the end of the section that this is a hard problem. So then the how question asks, how are we going to do this problem? So maybe we can use the answer choices and work backwards. That's one sort of idea. We can also maybe try to eliminate some answer choices based on what doesn't look right, what looks funny, what doesn't really match the other answer choices. That's always going to be a gamble though. It's not a surefire way to get the right answer. But we could do that. Or we could not answer this question. We could skip it, which gets us to the who question, which is, are you going to complete the problem or are you not? So let's jump back to the how question here and talk about how we might want to solve this. Note that the figure is not drawn to scale. That's a big that kind of noise, because we really like it when figures are drawn to scale, because then we can use estimation to solve and it's real nice, and we enjoy doing that because we don't have to use geometric proofs and stuff. So this is kind of a pain in that we're told that it's not drawn to scale. A lot of the geometry problems on the SAT are drawn to scale, or at least we can assume they are, but this one's not, so that's going to make this guy even harder to solve. So let's talk about how we can do this. First of all, there's an answer choice that I can eliminate right off the bat, and the way we're going to be able to see that is, let's start talking about what we're given and marking anything on the diagram that we can. That's the best place to start for a geometry problem. So what are we given? Well, we're given the altitude is h, which is already labeled here in our diagram, and then we're given that the base of this pyramid is a square. So we can mark that if we want with these little right angles to show that it's a square. And if it's a square, we know that both the length and the height of the base is m. So we could mark this as m just to show that those two sides are equal because the base is a square. And then it tells us the four edges meet at V, the vertex, and have length E. We see that, so this edge is E, this would have length E, this would have length E, and this back edge here, they'd all have length E. And then we're given, this is sort of the most important information that we're given. We're given that E equals M. Now, let's talk about what we're actually solving for here. Notice they're asking us to find the value of H, so I'm going to circle that. A lot of times it helps to circle what we're solving for, we want to know h, and then we want to know it in terms of m. This is really important that we want it in terms of m and not in terms of e, considering that e and m are equivalent. So here's what we're going to do. Since e and m are equal, I don't want anything in terms of e. I want it in m. So I'm going to replace the edge, length e, with length m, knowing that e and m are equal. All right, so now that I have that, we can notice something about one of the answer choices. So they ask us, what is h in terms of m? And we have a couple of these answer choices that seem a little maybe too obvious to be right. Look at C here. That tells us that the height is equal to one of the sides of the square base, which seems a little too obvious to be true. So this would be an answer that if we were just going through this problem and trying to eliminate something as quickly as possible, that might be a good one to eliminate. We wouldn't be able to eliminate it with complete certainty, but we could eliminate it with maybe like 95% certainty, just based on the fact that it just seems too obvious to be right. So I don't really see any other answer choices based on what we've done so far that look like we can really eliminate them. So from here, we're going to have to go on and we're going to have to do the geometry. So here's where we're going to start with this guy. I'm going to start by drawing some of these parts of the pyramid separately. So I'm going to start with the square base. And I'm basically just reproducing what we already have, but I'm separating the pyramid into some of its component parts here. So this is the square base that has side M, and then I want to draw one of the faces. Now all of the faces are going to be equal, so all of the four faces of this pyramid are going to look like this, where these represent the edges of the face of the pyramid, and this here represents the side of the base. So we know that the side of the base is M, and we said that the edge is equal to E, which is equal to M. So look what happens when we draw the component part of the pyramid that represents one of the faces. What kind of triangle do we get? Well, we get a triangle where all three sides are equal. They're all equal to M. And we know this is an equilateral triangle. And the cool thing about equilateral triangles is not only are all the sides equal, but all three of the angles are equal. So this angle is equal to this one, is equal to this one. And the cool thing about that is we know in equilateral triangles, if all three angles are equal, all three angles have to be equal to 60 degrees. So that's kind of a cool thing we can note there. And I'm actually going to write that in, that those angles there are all 60 degrees. Okay, so from here, let's talk about how we can solve for h in terms of m. One tempting thing to do here is try to solve for the volume of the pyramid and find h and m that way. The problem with trying to do that is that we're not given the volume of the pyramid. So if we solve for the volume, we're going to have too many unknowns in order to solve for h. So we could try that, but once we do that, it'll lead us to a place that we don't want to go to. So if we can see right away that that's not going to work, we'll be better to not solve for that. Instead, let me draw something on the original diagram here that might help you see a way that we'll be able to solve this thing here. So what did I draw? Well, I drew part of the diagonal of the base. I drew half of the diagonal of the base. So in our component part here that represents the base, this is what I drew in. Now, why did I draw that in? Well, because if we look at what I'm outlining here, this is actually a right triangle because the altitude intersects the base and makes a right angle here. So what I've drawn is a right triangle. Now, if we're able to get this side of that right triangle in terms of m. This side's already in terms of h, and the edge here of the right triangle is m. So if I'm able to solve for this part right here, then I can use possibly the Pythagorean theorem to solve for h in terms of m. So that's our game plan. Let's see if we can execute it. All right, so I'm going to reproduce the right triangle that I just drew there. All right, so this is our altitude that I've drawn. This represents this half of the diagonal here on the base, and this right here represents the edge of the pyramid, which we know to be m. Okay, so now how am I going to solve for this half of the diagonal of the base? Well, actually, we can do that pretty easily. And we can do that by solving for the whole diagonal and then just splitting it in half to find half of it. So that's pretty cool. So let's do that. So in order to find the diagonal here, how can I find it? Well, I can just use the Pythagorean theorem, right? Because we know the triangle has legs m and n. So the hypotenuse there, hypotenuse, fun to say, hard to spell, but I think I got it right. The hypotenuse is going to be equal to the square root of the legs squared. M squared plus m squared, which simplifies to the square root of 2m squared. So now I'm required to do a little bit of algebra here to simplify this. And the algebra that I want to do is I want to separate this 2 from this m squared. So one of the laws of algebra says we can separate two things under the square root and write it like that. Now if I do that, the square root of m squared just simplifies to m. The square root of a square just simplifies to whatever it is that's being squared. So that simplifies to root 2 times n. So now I have the hypotenuse of the diagonal of the base, and in order to now find half of the diagonal of the base, because I just want this part, and we solved for the whole diagonal, I'm just going to divide this by 2, and that gives us half of the diagonal, right? All right, so this, remember, represents half of the diagonal of the base in the pyramid, and that represents this leg of the right triangle that we drew in. And now, finally, it looks like we're going to be able to solve for h. And we're going to do that using the Pythagorean theorem that says the hypotenuse squared is equal to the sum of the legs squared, h squared plus this guy squared, 2m over 2 squared. All right, so now we got to do some algebra, and I'm going to need to actually square this term here. So when I do that, I get, and I'm going to move this up slightly so you can see this. So when I square this term, I get, and I'm going to rewrite what I have here, I get root 2 squared, because I can distribute the squared to every term in here. I get root 2 squared, which is just 2, and then m squared over 2 squared, which is 4. All right, so now from here, you probably know how to solve this for h. It's just a little bit of algebra. The way I like to do it, and you don't have to do it this way, is multiplying both sides by 4 so that I can get rid of the fraction. And when I multiply both sides by 4, what I get is 4m squared is equal to 4 times h squared plus 4 times 2m squared over 4, and the 4's there are going to cancel, and so I'm just going to get plus 2m squared. All right, now remember I'm solving for h, so I want all the m's on one side of the equation and all the h's, which is in this case 1. on the other side of the equation. So I'm going to go ahead and I'm going to subtract 2m squared from both sides, which gives us 2m squared equals, these cancel out, 4h squared. All right, so this is looking pretty good. Now all I'm going to do is divide both sides by 4, and oh my goodness, I am running out of room. When I do that, these are going to cancel out, and we're going to move up here. Oh, this is getting messy. I hate this. I am so sorry. 2 divided by 4, m squared equals h squared. We can simplify this 2/4 to 1/2, or just m squared over 2 equals h squared. And oh my gosh, we are so close to being done, because how do I solve this thing for h if it's solved for h squared? I just want to take the square root of both sides, and when I do that, I get the square root of m squared over 2 is equal to h. Now, unfortunately, is this one of our answer choices? Let's take a look. And scanning through, nope. So what does that mean? It just means I'm going to have to simplify this thing a little bit further. And in order to do that, again, laws of algebra, in terms of squares and square roots, we can always separate the square root in the denominator and the numerator. So we can write the square root of m squared over 2 as the square root of m squared over the square root of 2. And the square root of m squared just simplifies to m, and we get m over the square root of 2, which is a, and I very much apologize for the messiness. Yes, I'm sure I am much messier than you, and I am very sorry for that. Yeah, I almost want to redo this video because I'm dwelling on it and it hurts my eyes to look at it. So I'm very sorry.